All right, this will be a video for 8th grade. This is page 158 for 6.1, 6-1, representing or identifying and representing functions. So I want to talk about really quick what a function is. A function is a relationship between like x and y, like what we've been using, where all inputs only have one output. Okay, all inputs only have one output. So I'm going to give some examples. So we'll have functions and we'll have not functions. Okay, and I'm going to give 4 different types of four different ways we can represent these things. So the first way, we're going to call it, we'll just say it's a graph. So we have a graph. Actually, I don't want to do graph first. I'll do, it's a table. So it's a table where we have input and an output. Normally this is x and this will be y. When we're talking functions, it won't be y, but we'll get to that eventually. So let's say the input is 0, 1, 2, 3. Okay, and it doesn't really matter. 5, 6, 10, 10 again. So now the question here is, all inputs only have one output. So let's check it out. The input of 0 has one output. The input of 1 has one output. It's 6. The input of 2 has one output. It's 10. The input of 3 has one output. It's 10. Doesn't matter, these are the same number. Doesn't matter. And I'll explain that when we do the next one's going to be a graph. So let's see. Something that's not a function. Input x, output y. So here's one that would not be a function. So let's see. 0, 1, 2, 1. So this will be 5, 6, 10, 10. So the input of 0 is 5. Has an output of 5. So that's good. Input of 1 has an output of 6. The input of 1 has an output of 10. So this is not going to be a function because the input of 1 has 2 outputs. Okay, one of which is 6, the other one is 10. So instead of it being a function where all inputs have only one output, the input of 1 has 2 outputs, 6 and 10. So this is not a function. Okay, so let me now show you what this would look like on a graph. And I'll use these exact same examples. So we have the point 0, 5. It's about right here. We have the point 1, 6. It's about right here. The point 2, 10. And the point 3, 10. Okay. And when we're going to look at a graph, we're going to do something called the vertical line test. If you've been doing number 8 on Mountain Math, we've seen a lot of these already. But let's talk about the vertical line test. That's where you can draw vertical lines. And if you only hit one point on any vertical line, then it's a function. So this passes. But let's graph the one over here that we'd already decided was not a function. We have the point 0, 5, 1, 6, 2, 10, and the point 1, 10. Okay, so now we should see my vertical line test is good right here. It's good right here, but right here on this one, we have 2 outputs. So this is not a function. It fails our vertical line test. One of these vertical lines hits our function or our input and output. It has 2 outputs here. So this is not a function. Okay. The next way we can represent these is called a mapping diagram. It's where we have our inputs and we have our outputs. And it's usually like this, and there's usually our lines. So our inputs here were 0, 1, 2, and 3. And our outputs are 5, 6, 10, and 10 again. So I'm not even going to write another 10 here. But what I see is 0 has an output of 5. 1 has an output of 6. 2 has an output of 10, and so does 3. But is there any number here that has more than one arrow coming off of it? Is there an input that has more than one output? There is not, so this is a function. But looking at our other one over here, so we have our input, we have our output, input and our output. On this one we went 0, 1, and 2. In our output we had 5, 6, and 10. So 0 went to 5, 1 went to 6, 2 went to 10, but also 1 went to 10. Notice right here, 1 has 2 outputs. So this again is not a function. And then the last way we could represent these would be with ordered pairs. And it's the same thing as what we've written here in a table. It's just that instead of in a table form like this, it's just going to be written in ordered pairs, which are points. So I have the point 0, 5, 1, 6, 2, 10, and 3, 10. Okay. I see that every x only has one y, so I'm fine on this one. But this one over here, I have 0, 5, 1, 6, 2, 10, and 1, 10. I see there's an x here and an x here that have different y's. So the input of 1 has multiple outputs. So this is not a function. So I'm going to go ahead and move my face down here a little bit. I might move it around depending on what type of problem we're working with here. But let's go ahead and solve 1 through 6 here. So we have complete each table in the row with x as the input. So here, write a rule. So looking at this, we're going 2 to 40, 5 to 100. I can see this as times 20, times 20, times 20. So this is proportional. Times 20 and times 20, right? So this is going to be 200. 10 times 20 is 200. And then 20 times x is just 20x. Okay, so this is a function. It's a proportional line. And proportional lines, if we graphed a proportional line, it's going to look like this. It goes through the origin, but it passes our vertical line test. So it's set. Looking at this one, 2 to 1, we cut it in half, right? We went 2, cut it in half as 1. 10, cut it in half as 5. So times a half, times a half, times a half. So we have x times 1/2, or x divided by 2 is the same thing. So this will be 15. 30 divided by 2 is 15. If we look at number 3, we're going, 1 times 2.25, 3 times 2.25, 6 times 2.25. So let's do 2.25 times 12. Oh, this is 2.25 times x. So 5 times 2, 10. 2 times 2 is 4, plus 1 is 5. 2 times 2 is 4. And now we're in the tens place, so we'll add our 0. 5, 2, 2. Add these together, 0, 10, 4, 5, 6, 7, and 27. Move our decimal over 2 spots, so this is 27. All right, number 4 and number 5 and number 6. We need to determine whether these are functions or not. So number 4, I'll move my face here. Number 4 is a mapping diagram. So we need to decide, does every input only have one output? So our first box, first circle is our input, output. So the input of 3, how many outputs does it have? It's only got one arrow going to 12. So it has 1. 6 has 1. 9 has 1. 12 has 1. So this is a function. Because each input only has one output. Number 5. Number 5 is like a table. Okay, so we need to look at our input and see if we have any duplicates. Because right here on our input, we had 2 1s. So let's see, I have 3, 4, 5, 4, 6. So here's our key right here. 4 has 2 different inputs, 25 and 35. So this is not a function. Input, 4 has 2 outputs. If we were to graph this, it would look something like this. So we'd have 320, we'd have 425, 530, 435. Our vertical line test fails right here. And then 640. Our vertical line test failed right here because we have two things at x equals 4. So it's not a function. Number 6. The graph shows the relationship between the weights of 5 packages and the shipping charge for each package. Is the relationship represented by the graph a function? Well, we've got a graph. What did we do on our graph? You see these blue lines? We did this vertical line test. So let's do a vertical line test on this graph here. I see there's a point right here, but it's the only point in that vertical line. It's the only point in that vertical line. Only point, only point, only point. So this is a function because it passes the vertical line test. All inputs have only one output. All right. Number 7, I'm probably going to have you do this one on your own, but I've really already answered it for you. So what are the 4 different ways of representing functions, and how can you tell if the relationship is a function? Well, one way here, let me get another color so it's easy. You can see what I'm talking about. One here was a table. One was a graph. One is ordered pairs. And the last one is a mapping diagram. Now for each of these 4, it says, how can you tell if the relationship is a function? Now I told you up on top here in red what a function means, okay? So there's 4 ways we can represent functions. How can you tell if a relationship is a function? So go ahead and answer that one on your own. Here's 1 way, 2 ways, 3 ways, and 4 ways to represent functions. And then to help you out with the second part, it's up there on the top on red.